I've been working at FAANG for about 6+ years. My current level is L6, and I have interviewed about 100+ candidates. A lot of them for system design, a lot of them for coding. I have sat in hiring committee meetings and stuff like that. So hopefully this interview will be helpful in that regard. My core expertise are in machine learning, mostly in images and videos. But in past I have kind of done all sorts of stuff. That's about me. I wanted to understand what kind of roles are you hiring, are you kind of applying, and so that I can tailor the interview according to that.
Sure. So I'm applying for e-commercial role, especially the risk management system, something like that.
Mm-hmm.
So
okay.
Yeah.
And what is your expertise? Are they in back end, front end? What kind of
back end?
Back end. Okay, cool. And the roles you are applying are also related to back end, I assume, right? All the back end roles.
Yeah.
Right? Cool.
Yeah.
Cool. Okay, that's good. And may I know what kind of level are you targeting?
I'm targeting maybe. Actually, I'm targeting L4. So.
Okay. No, that's okay. Yeah, that's good. No, it's good to know so that I can kind of calibrate my feedback for that role. Cool. Fantastic.
You can assume. Oh, so if I perform really bad, then you can assume that I'm applying for L4. But if not, you can use high level, maybe L5 strict to give me feedback. I don't know.
No. I can discuss this later also. But typically, you can when you are reviewing a candidate. Let's say if recruiter has mapped you to L4, right? So then most of the time, the feedback will be, so the interviewers will be looking for L4 signals from your interview. If you do extremely well, extremely well, more than L4, right? Then they might recommend for L5. But that rarely happens. That is like 1 in 200 candidates, right? So that's very rare that they might give you a feedback for L5. But let's say if you had applied for L5, they might give you feedback for L4. That can happen. But L3 does not usually do design questions. So I would say that if it's L4, let's focus on L4s. And of course, I'll tell you that what would have made it L5, right? So I'm happy to tell that later. Okay, cool. So these interviews are mostly, although they are scheduled for 1 hour, typically they are done 45 to 50 minutes. That's what kind of the real game is. And then the 10 minutes is, introduction and question answering and stuff like that, follow-ups. So let's do it that way. Let's try to do it in 45 to 50 minutes, depending on how we are doing. Sound good?
That's good.
Okay. So we are starting at 10:08. So I don't know what time is in your time zone, but you can see a clock on the bottom. It says 6:30 or something, So let's try to do that 45 minutes from there. Sounds good. Okay?
Sure.
Okay, and you can use the whiteboard feature. I can comment. Okay, I'll just delete this whole thing.
Yeah, okay. I'm already in the whiteboard.
Okay, you're already on the whiteboard. Fantastic. Okay. I don't know if it's easier to paste question. Okay, sounds good. I can paste question here. So here's the question. Oh no, wait 1 second. Sorry. Sorry. Okay. So 1 second. I gave you a wrong question.
Yeah, it looks like some security.
Oh, I know. No, I do conduct coding interviews too. So I think the wrong thing got pasted. Sorry about that. Okay.
job scheduler that runs job at a scheduled interval.
Yes.
Uh,
So, and I can tell a little bit more about, see, the job schedulers are used everywhere in the industry. One example is that if you want to schedule a job to do something in company, for example, roll out this PR or roll out this code at certain time, right? Or run this query, SQL query every day, and that SQL query will do A to B. So the jobs can be anything. Or if you are, like, say, if you're building a payment system, then you might schedule to pay bills on every 30th of month, or you can schedule it every week or whatever. So something like that. So job schedulers are everywhere. But here we will focus on designing a general purpose job scheduler. So what will be the job itself? You don't have to worry about that, but we are mostly focusing on the scheduler part of things.
Oh, okay. So, will this be a service or just a background thing? I don't know.
It's the whole
Will this be a
system.
service?
It's a
Oh,
whole
system.
basically. Yeah. So
Okay. So, how are our clients going to interact with this job scheduler?
yeah. What are your suggestions?
Well, my suggestion is maybe we can do something like AWS Lambda, so our clients can upload their job in Python or in a Docker, I don't know, and make it run in a scheduled interval.
Sounds good. Yep, that works for me. Yep.
Image or a Lambda package.
Okay.
Okay. So okay. Let me think. Will there be any size limitations for this job?
Yeah, you can expect. Excuse me. You can the size limitations. You can say that the job is 5 megabits. That's 5 MB is the size which it needs. While that's the average size I'm telling. It needs to run the job.
Okay, so 5 MB memory or total?
5 MB memory in memory. Disk, you don't have to worry. Just assume that you have something like EFS or whatever, like infinite amount of disk is available.
Okay.
Yes.
Okay, that's cool. Let me think. Is there anything else I should notice for this system?
You tell me what kind of. I would expect you to. I'm happy to answer, and maybe you tell me what you should know to design this.
Sure. So there should be a website or something that client can do the interaction, and will this interval change?
The interval?
Yeah.
So interval is, of course, I mean, you can say that interval is a timestamp in the future at which you want to run, basically. So.
Okay, so this sounds good.
And it is changeable, yes. So you can change your mind. So think of, like, say, in case of payments, you wanted to send money on 30th and you change your mind. Now you want to send on 15th. So that should be allowed.
Okay, cool. Okay, and we don't care about the job detail. So
yeah, as you said, like, you can wrap it into some like Lambda, or you can run and just think of it, whatever, like a batch script or whatever.
Okay, so so we have functional requirements now.
Mm-hmm.
So first we can upload, change existing
Mm-hmm.
job information maybe. Yeah. And do we need any message from this job, like, oh, do we need to tell our client that, oh, your job is running
Yeah.
and it's done?
Yeah.
Okay.
Yeah.
So
Yeah. And it
messages.
will be nice, because otherwise, how will the client know how is your job doing?
Okay.
Mm-hmm.
So we need a message.
Yeah.
Pushing the service.
Yeah. So something like, you can say a status. I would use, like, basically users should be able to track the status of their jobs.
Okay. Cool. So we have these 3 functional requirements and non-functional. So first, it should be reliable.
Mm-hmm.
Like you said, it should be run maybe tomorrow, but it didn't run. That's not acceptable. So
Mm-hmm.
reliability is our first.
Mm-hmm.
And one more thing. If a job is running and a previous job is running and it didn't finish, will we start a new one, or should this be a setting that should we allow clients to decide whether we should run a new one if the previous one is still running?
Yeah. So I think what you're referring to is the deduplication kind of case, that where you are running same. Okay. So yeah, deduplication, you can, I would say we can come to it as an advanced feature, but that's, I wouldn't bother about it in the beginning, at least.
Okay.
Yeah.
So let me show you like this. Okay, cool. So the jobs, how long will it take? Maybe several seconds. Can I assume this?
Yeah. So you can assume that a job takes like a minute to run on average. And let's say that jobs, they can all run on CPU. They don't need any.
Okay, I see. So job, we can assume we have a ECS or EC2 running the job, so that's not our concern. Okay, so how many users do we have?
Yeah, so let's assume that up to 100 million users can use this service.
100 million, and how many jobs are they going to use? Maybe.
Let's say that they do one job every day.
One job every day.
Yeah. On average. I mean, of course, it's average. Some will do more, some will do less. Yeah.
Okay. That's fair enough, I think. So okay. Cool. So the next is maybe scalability. Scalability, as we have this much users, and it might take we assume 1 MB for every job, and it's multiplied by 100 million. It's like let me think how much it is, but so something like this, and it should be like holy crap. It's like this number. So we need 500 terabytes just storing the jobs. Okay. That's not a problem.
So by the way, so 5 megabyte, when I said, that is the memory when job is running. That is the amount of memory it needs to run. The storing the job and all that, you can just think about that goes in the disk, depending on how you're storing it, maybe. That part I'm not, just storing the image, as you said, like AWS Lambda or something like that. That part I'm not including. This was, if job is running, then that is the amount of memory it needs or RAM it needs to run.
Yeah, I see. So how large will the job be? We don't care about it, or
we don't care about it. But if you care about it, let's say that each job information is 1 megabyte.
1 megabyte.
Yeah. That's the like AWS Lambda stuff things.
Okay, so 100 terabytes in total.
Yeah.
Cool. So scalability and of course fault tolerance. And we need monitor it. Okay, so now we have 3 functional requirements and 4 non-functional requirements. I think that's good enough. Any questions so far? Anything you think I should improve? Or
yeah, I mean, so sure. Let's go further. Yeah, I'll have more questions. I want to see how you're proceeding.
Okay, yeah. Okay, cool. So first we have a client here. Oh, wait a minute. Let me define some entity first. So we have job entity, maybe job name, ID. Maybe job don't need a name, so job ID, but it can have a name. So job name, job description, something like that, and job code or image. So if a code is a code, then we will store this code here, maybe. If an image, we will store URL for the image, maybe in somewhere else. Okay, so that's job entity and maybe user entity. User ID, their jobs. Oh, job owner. So now we have only 1 job for every user every day. Maybe in the future we will have more. So let me keep this. Keep this. So these 2 entities and maybe APIs. So first we need to upload jobs. You can use a post or something. I don't know. Next we need to edit. So, yeah, we cannot only change existing job information. We need to create, read, upload, update, and delete. Delete. CRUD. No.
Yeah. So let me. I know you are trying to get into a little bit more into like how APIs and jobs will look like. Maybe give me a high level of kind of picture of how you're designing.
Sure.
I don't have an idea like how you are thinking of doing this.
Sure. So first we have a client here. This one is a client, and maybe a load balancer here.
Okay.
And load balancer. And then client will upload their job to the load balancer, and the load balancer will firstly, I think, upload to maybe S3 bucket somewhere to store the user ID. No, I mean to store the image or anything. Okay, and then
let me try to understand. So you have a client, and the client gives the job information, and what else? What else information will it give to the load balancer?
So maybe job details.
Yeah, let's say the whole job details is like a zip file or whatever. Like, that's not important. I'm interested in like what more information will it give, and what will be the how on S3? How will it look like?
You mean for APIs or for how clients are going to upload the jobs?
Yeah, I'm on S3. It's just so we will just dump it in a directory. Like, what are you gonna do?
Sorry, I put it wrong. There should be a backend here.
I'm saying that there are 100 million users, right? 100 million users are uploading their jobs. How are you going to dump it in S3? How will the schema look like? Will you just create one bucket and then just dump everything there? Or like, I'm trying to understand that part.
Okay, I see. So it shouldn't be just one S3 bucket. I'm thinking maybe so first we should upload to the backend service, and the service will decide how to upload them to buckets. And looks like it's not acceptable that we create a bucket for each user. So maybe we can group them.
Okay, maybe what I'm not getting is that, okay, tell me what is the request looks like for your client. What kind of request looks like, and what is kind of response the client will get. So I'm trying to understand these things. I know you were trying to get into these details. What I'm trying to understand is that what will be the request and response format of these things.
Okay, so like this, you mean? Maybe some job.
Yeah, sure. Yes. I mean,
job name.
Okay.
Or trigger time.
Okay.
And maybe they will upload some files.
Okay, yeah, sure. I would say that forget about the job related file, right? Okay, let's work with job name and a timestamp, right? And you don't have to include files anywhere. I want to remove that completely from you. Let's say the job is to print your name. That's it. Let's say so just you don't think about it anymore. Okay. Job is to literally print user ID. Everybody will trying to do that. Now tell me that how are you going to store the jobs, and how are you going to schedule them and stuff like that.
Sure. Okay. So here we have a database here to store all the metadata of the jobs, and we can directly for now, and we will scale this up later. So currently it's just from backend directly to database, and forget about this S3 bucket. So about this database, so we are let me think. So clients are there are the read and write are almost the same, I think. Not both are not really much. Like users are, I assume users are not going to change their jobs every day. So currently I'm just using one database here. So if there's problems in the future, I will change it. And
Okay.
Backend directly to database, and there should be another maybe a scheduler here. And let me think. How are we going to schedule these things? Scheduler need to know what's the next job we are going to run. So so backend should one more thing. How are we going to run the job? Okay. So scheduler need to run the job, and I think how is it going to run the job? Let's see. We maintain a queue somewhere.
Okay.
I don't know how to maintain this queue for now, but we will discuss it later. And this queue will tell the scheduler what's the next thing that it need to deploy. So this queue will go to this scheduler, and it will do something to maybe create ECS or something else.
Okay.
Let me draw something here.
Okay.
Run.
Okay. Yeah.
Deploy. Okay. And we don't care about how it's going to deploy.
Yeah, that's very nice. So I'm happy with that you pick it up, you give it to somebody who will handle the running part. Cool.
Yeah. And also after it's scheduled, we need something. We need some service to push the message to our client.
Okay.
So this could be a third-party thing. Maybe push job data.
Sounds good.
Yeah, and it will directly go to our client.
Correct.
or some, I don't know. We don't care about this part. And so now our question is that how are we going to maintain this queue?
Exactly.
Yeah. So what I'm thinking is that so we can have a cache here. Let me think about it. No, we don't have cache. maybe we don't. We can directly query database, and the database will tell the scheduler, what is going to be the next, and this could be done by scheduler, and also could be done by another service, maybe. And that service is going to put the things to queue. The message queue. I think so we can have another service here, and let's discuss which solution is better.
Okay.
Okay. So I don't know how to call this circle, but we have a service here, and its job is to read the database and prepare for the queue, and the queue goes to the scheduler. So if the scheduler directly reads from database to decide which job we are going to do next, then we don't need this queue. And why I think we need this queue is that queue can this message queue, maybe a Kafka, I don't know. This message queue can provide some consistency, like if something wrong with the scheduler, maybe it broke, and we will have to and we get a new scheduler here, and it will need to query the database again, and I think that's not efficiency enough. But if we have a message queue and it's just handling the messages, then after this schedule is down, then we can directly move the offset of the message queue to make this system work again. So I think we have this message queue is can provide some consistency. So that's the reason I keep it here. And why I'm having this service here is that.
Okay, let's call that box publisher. I just want to give it a name so we can use something. Let's call it publisher, because publisher is the pub P-U-B. Yeah, publisher. Yeah. Okay. Yeah.
Cool. Okay. So this publisher will. So first, I think there are two jobs for this scheduler. One is that so if there's no this publisher, then the scheduler have to do its own job and do the publish job, and so Splaces will make our easier to scale. That's the first reason. And second reason is that so I think one service do one job is better for maintenance. So scheduler just do the scheduler job, and publisher do the publish job. So I think that's fair enough. Okay, so let's see, our functional upload already done, and CRUD already done by this, and message data service done by here, and run the job done by here. So okay, we meet all the functional requirements.
I think CRUD is not that easy, because let's say, especially around, can you think of cases where it's not as easy as you said it's done?
You mean this one? How this is done?
Yeah. Can you think of some? There's more to it. I want you to think about.
Sure. So for create, it's just this one.
Sure.
And for read, I think read can also be handled by this backend, like query by job ID or and update. Oh, I see what you are talking about. But if it needs some update, then there's a problem. We're delayed. Yeah, you're correct. Okay. So if we want to update the job, then so first step is that it still need to be update to the database, and we can have a, call it change data capture. Did you see here? And the publisher will know how the database is changed, and this can directly from database, or the backend tells the publisher to do something I mean, it could be like this. Yeah.
Okay.
But I think
Let's step back. Okay, tell me how it's working, especially the updates.
it's actually okay. Sure. So let's see. So for example, we change the time step from maybe morning to the afternoon. Then we need to do two things. For the publisher can send two messages to the message queue. The first one is that disable
What is the time right now? What is the time right now? You said morning to afternoon. Okay. So right now it's
update from morning to afternoon.
And what is the current time?
Excuse me?
What is the current time? Like, so
maybe tomorrow.
So let's use number. Let's say that I had a scheduled job at t equals to 50, right? And I updated it to t equals to 75. Now tell me how is your behavior changing based on what is the current time?
Okay, I see.
Did you see the question?
No. Can you type the time here?
So right now could be t equals to 0. Right now could be t equals to 45. Right now t could be 55. Right now t could be 85. Right? It could be anything. Because
85?
Yeah. So what I'm saying is that you can update the job anytime you want. I'm trying to understand how will the update work, and think it as a let's say I'll take an example of payment service, right? In case of payment service, I wanted to send money tomorrow, and tomorrow at 8 a.m. and at 7 a.m. I decided that I want to send money at 7:30. I was planning to send at 8, but now I want to send at 7:30. Or I can, or let's say I wanted to send at 8 a.m. and at 7:59 I decided that I want to move it to 8:30. Or it is 8 a.m. and I had scheduled at 8 a.m. and now I'm trying to cancel it.
Okay, so we have three situations need to.
Yeah, so I want you to. This is just a hypothetical example, but these are the cases I want you to consider. That how are you going to handle multiple of different updates at different timestamps, and how will the design get changed because of those?
Okay, I see. So so in general case that it's not in a rush. Let me think. I think we can directly do this thing. Maybe is this a good choice? I'm not sure. But the backend will first handle your update request, and it will change the database, of course, and it cannot use this message queue because the update will be the at last of this message queue. So we will skip this message queue here and directly backend to this scheduler to tell the scheduler, oh, we are going to cancel the money pay in the next minute, and the scheduler have to do this job immediately. So scheduler will tell here to maybe drop terminate the instance or send update to the maybe send a new one. Let me think. So if change time, we can terminate the old one and deploy a new one. It's no harm. So so change and delete, I think now is fulfilled.
Yeah, sounds good. What kind of database will you consider for this?
The database. Okay. So now I think we have only like 100 users and 100 terabytes. So I prefer non-SQL DB because it's cheaper, and our case do not require any SQL relational requirement. So I think non-SQL should work for this situation.
Okay.
And maybe.
So how is publisher going to know what to run, what to enqueue using non-SQL DB?
Query by time, maybe. Listening to the change data capture.
How is that gonna help? I mean, because change could be anywhere. Like I might say that move it a year from now, 6 months from tomorrow. So I'm trying to understand how is publisher gonna benefit from listening to changes.
So it can only, let me think. So publisher, maybe there's a job status here. Let me add this. So publisher can read by query by job status and to see which one is just added and put it in the message queue. So
are you going to put everything to message queue? Like
no, just create. Like we are planning to do the changes directly from backend to scheduler. So this publisher looks like it's not necessary.
Let me add this thing that let's say that you can schedule up to 1 year in future. You are allowed to, any of these 100 million users can schedule any job up to 1 year in future.
So one year?
Yeah, up to 1 year in future. So are you saying that every single time there is a job creation, it goes to the message queue?
Yes, I was planning to do this, but looks like it's not a good choice. So I'm planning to directly do this. How can I change? I don't know how to change it. So we are going to delete this and directly scheduler read from the database.
So okay, so tell me what kind of queries will the scheduler do on the database?
So scheduler will query by the status. So if a job is already running, then the scheduler will skip it. But if it's just created, and it will.
So the query will look like, if I understood correctly, that select a star from just job table if job status is not cancelled or not completed, something like that. Is that what the scheduler is doing?
Yeah, I think so.
But that will return 100 terabytes of records.
Then we can have multiple schedulers. We can scale this into multiple.
So they will all be calling with the same thing, and they will be getting these, I don't know, couple of still terabytes of records.
I'm sorry, your microphone.
I'm saying like I'm saying that so the scheduler will be making these queries and they all be getting couple of terabytes in as a result.
You mean initially?
No, I'm trying to understand what will be the query. Can you write like a high level query?
Okay, sure.
That yeah, let's start from, let's say, jobs. Yeah. Okay. Yeah. Okay. Okay. So how many records will this query return?
So we can ask this backend to push the newly updated thing to the scheduler. So this query will not be too large. Most of the thing will come from this arrow.
So scheduler, I'm trying to understand how will a scheduler maintain such a large amount of records?
Let me think about it.
So you are giving me information for our next 1 year, and I cannot deploy it. I cannot send a status because job needs to run 1 year from now. So what should I do with it? What should scheduler do with this information? You are telling me this job needs to be run 1 year from now. What will the scheduler do with all the information? Where will it keep it?
I see. So maybe start time in a range, maybe just in 1 hour.
Okay. So now you got these 1 hour records, right? So yeah. Now, of course, this is also a very large number. So now, how do you propose to handle this? Because one scheduler cannot run or deploy so many jobs.
Yeah, you are correct. Then maybe just several seconds.
Maybe, okay, let's say several seconds. So now, because everybody is calling, like you have many schedulers, right? That's what you said. Like you have many schedulers, and they are all calling this with this query, and they will all be getting similar responses, right?
Yeah.
So is that a problem? It's not a problem.
So this will be a problem as we are going to correlate it every several seconds. So there will be a lot of queries here.
There will be a lot of queries, and there will be a lot of duplicate results, which will be given to that. Queries, let's say queries NoSQL can handle. I'm curious, how do you know that? Yeah, how are you going to prevent scheduler 1 from scheduling the same thing which scheduler 2 has already done it?
Yeah, I know your question. I already understand it, but let me think about how we are going to handle this. So these schedulers can definitely can get same jobs. So we have several plans. Our first plan is to do something like consistent hash and for every job, maybe job ID, and in this way we can assign the job only to one scheduler. That's a solution. That's an option.
Okay, so how will you? Let me try to understand again this part. So a scheduler 1 makes a request. How consistent hash is going to help you in avoiding assigning it to another one?
Yeah, so we can query by the hash here, and maybe hash equal like something, like something, And in this case, this hash is always will same hash will always assigned to one specific scheduler instead of others. So other schedulers query will not get this job by this consistent hash.
Okay. Cool. Cool. Okay. Cool. Now that you have, let's say the scheduler got the things to run, right?
Mm-hmm.
And now what if after getting that information, it dies?
It dies?
Yeah.
The scheduler dies or the job dies?
Anything can happen. So tell me both cases maybe now. Good question.
Okay. So let's say the job dies. I think the job dice is more difficult in this part because a scheduler needs to know the status of our instance. So I think
I mean that's not hard. Let's say that whatever deployment service is, that tells you that gives you a long running operation, LRO.
Yeah.
And you can query, and that will tell you whether the job has failed or is still running. So you can query that information from deployment.
Yeah, I see. That's what I'm thinking too. Yeah, so scheduler can tell this, and so if the instance died, and scheduler will know this, and the scheduler will know the information of when this thing should be scheduled. In my opinion, I think we should tell the client first to say, oh, the job is bad for some reason, like maybe the memory is runs out. But if we can know the specific reason, then we will tell the client and ask them to maybe reschedule the job. I think this option is more makes sense. Like if something is you have to do that on that time, and if we don't tell the client, then maybe the client will miss something. So and they will blame us. So I think we should tell the client. And that's yeah. And so and let the client decide what to do next. And so that's what will happen if an instance dies. But what happens if a scheduler dies? So as I mentioned before, the consistent hash, it will automatically move assign previous the jobs assigned to that slide scheduler to some other schedulers. So that's why I'm using.
Sounds good. So let's spend one more minute on it, just a time check. So let's say scheduler died, right? And how would you reschedule the job? Because you still want to run the job, right? So can you tell me the state of database while all this is happening? What's happening? Like how will a new scheduler? You said consistent hash will make sure that new scheduler comes. Sure, but that new scheduler needs to know that where was it left behind. So can you tell me quickly in maybe 30 seconds that how is it gonna know that where are we right now? How much was done before that scheduler died?
Sure. So we can know what the scheduler get in the last query, right? So we can do the same thing to our new scheduler, and by a similar SQL query, and do the deployment.
Okay. Cool. Thank you. Yeah, I think that's about time. Do you want to discuss? No, interview is over, by the way. Interview is over, so you can relax a little bit, and we can more casually chat about it now.
Sure. Yeah. Thank you for your interview. And
how did you feel? How did you feel?
Well, I think I mean I might need to learn more things.
Okay, that's good. Was it helpful? Like, I know I was a little bit more aggressive than interviewer, but I thought this can help you.
Yeah,
Uh,
yeah, it definitely helped me.
right. Yeah, I know I went into very much too much details, and I thought that will give you an idea of like where to you do the time management at least. You know, initially you were doing a lot of things which pretty much every candidate does, and I feel like they end up wasting a lot of time by doing that. So you see, like later is when the interesting discussions were, and then, in the beginning we were talking about we'll put a load balancer and then let me design a job schema, and yeah, I mean it's interesting, but it's kind of boring as well. Like there's nothing interesting happening there, right? Like you said, job name, description, code image, owner. Yeah, sure. It's like, who cares? It's like anybody can do that, all that, right? So cool. But
I can't hear you anymore. Hi.
Huh? Yeah. So can you hear me?
I can hear you now, but not the past 1 minute.
I see. Yeah, no, I was saying that in the beginning, let me go over from the whole thing, right? If you want to see the whole feedback. So let me conclude. So you are applying for L4, right? And L4's typical expectation is that they can independently code. But the design, it's okay to get help. So L4s are not supposed to independently design. They can design smaller things. This was a bigger problem than an L4 scope. So I would say that it is a harder problem, and L4 will not do this in a real job. But it's good to know that you might be asked to design just the scheduler part of things, for example, or you might be asked to handle only the NoSQL part of things. But nobody is going to ask you to design such a big system as a L4. But having said that, right? And you are supposed to, of course, do extremely well in coding. And in design, you should be able to kind of, come up with the right high-level things, although you didn't do, even if you don't do so well in the, low-level details, right? That's the typical what, when somebody hires L4, that's what they are looking. That independently can code, can design with an assistance, right? So that's the expectation. And so now on your performance, I would say you are borderline for L4 based on this interview performance. If I was supposed to give you a rating, I wouldn't say you. Yeah, I would. If you ask me, if there's a, there's a reject, leaning reject, leaning higher, or strong higher. If there are 5 of these, I will give you like leaning higher, 3 on 5. So it's not, but the problem with leaning higher is that if you get another leaning higher in any other part of the interview, then you are not going to make it. But let's say that you got hires and strong hires in coding, and you got a leaning higher in system design, you might still pass the interview.
Okay, I think I already got a strong encoding part. So
yeah.
Okay.
So cool. So and this question is a little hard. Of course, this question I ask this question from everybody from L4 to L6. I ask everybody, and of course their performance changes, and that tells you, the signals tells you that what are you? Are you L4? Are you L5? Or are you L6? Right? Okay. So let me quickly go over the performance. The beginning, you did fairly well, I would say. You could have done better, but you did fairly well in terms of coming up with something like AWS Lambda and the size limitation and how you will deploy it, and then functional requirements and non-functional requirements, breaking it down. That is all good. I think you know how system design interviews kind of are set up. So you did in like first 10, 15 minutes, you were doing pretty decent, I would say. In case of functional requirement and in case of non-functional requirement, I would say that think about the problem, maybe close your eyes and think about it, how as a user you will use this product or whatever you are designing. I think that was not very clear. And I call it, life of a query or life of a user or user journey. You were not very clear about how a user will use it, this whole thing which you are designing. And this is where, let's say you were saying upload job and query existing job information, job status. That's good. But a nicer way of putting it this would be that I'm sitting on my browser, for example, right? And I can do what? I can schedule a job, I can cancel a job, I can modify a job, or I can see what jobs are there which I have scheduled in past. So a list a job. Very clear, right? So you are doing, but now this gives you interviewer a picture that, okay, so now you are thinking of a web page or you are thinking an app, which this is where these options are, right? Now, so you did collect the functional requirement, but you were adding requirements as we were discussing things like running the job or message status service. I mean, message status service is not a really functional requirement. The functional requirement is that you should be able to see the status of the job, basically. So that gives. So although these things are good, but they are not really the functional requirement. You kind of mixed up lots of server side stuff, more on client side stuff. So functional requirement should be more on client side, how things are, how this thing is going to use, basically. In terms of non-functional requirements, again, think of the functional requirement and then think about that to satisfy those functional requirements, what should I do? What should be my non-functional requirements? So they should be derivative of functional requirements. So it seems like you were thinking of like reliability, scalability, fault tolerance, monitoring, but you were not motivating them. That why do I need reliability or why do I need scalability? Scalability is sure. You saw the number, so you said that, right? But it would be nice to kind of talk in terms of, I need reliability because if my job status, if job is, I have scheduled a job, it doesn't run, then I might be in trouble. So that's why I need reliability. And then you write reliability. I need scalability because there are so many users and they are scheduling one job every day. There's too much QPS. So I need scalability. The fault tolerance part was extremely unclear when you wrote it. That why do you need fault tolerance? Unless you actually think about schedulers and all that and they're going down, it's not very clear why you need fault tolerance at that point in the requirement, right? Monitoring is good. Right? But monitoring, I to be honest, I didn't even work clearly what kind of monitoring you mean. Do you just mean that whether my job is working or not? So anyway, so these are the feedback on the beginning, right? Then you started designing all these job entities and APIs and user entity and stuff like that. You never discussed how are you thinking about it? So you jumped from non-functional, functional to directly all these details without any kind of, relationship, like where did all this come from? So maybe going into, at that point, it would be nice to put up some boxes, client, servers, databases, and stuff like that. Start putting those things. That's what I'm thinking. So a high-level design, I would put after functional, non-functional, maybe a high-level design, right? In high-level design, everybody puts these load balancers, right? In the beginning, it felt like you were using load balancer, will call the S3 bucket. I would ask you to read about load balancers. What do they really do? Right? So load balancer will not talk to backend directly. There will be a front end. Load balancer is actually pretty dumb. They actually just, a request comes, they redirect requests to many web servers. They are not smart. They don't do anything, to be honest. Like a request comes, it just balances it to something. So It's a hardware. It doesn't have the semantic understanding of anything. It really doesn't understand that part. All it does is it bounces around the request all over, right? So either don't put it. If you're putting it, then you be sure about it what it is. So right, you could have just said that I have a client and I have a server, and a server will be server will use the will get the request. I'm running a HTTP server, and that gets the request, and then we forward it to backend and stuff like that. Just to keep it simple in the beginning, and then you put load balancer if you need it, but don't put things just because that's how every single diagram looks like. Cool. Now, yeah. So now you came to backend, and then in the beginning you were kind of confused, like I'll use S3 buckets. So that's where, because you didn't really give me an idea about how your high-level information looks like you didn't tell me how your request looks like and how your responses look like, and what will be your APIs, which you are going to serve from the front end. So these are the three things. You don't have to write details. So APIs would be, let's say, upload, modify, cancel, list. These are the APIs. Simple, right? And they are directly related to your functional requirements. So you can have 4 APIs, right? Then request will have what? A user ID that tells you whether the user, who is the user. It will have a timestamp, and it will have, let's say, a job location. And that location could be the S3 path that you as a user went ahead and uploaded your job somewhere in S3, and all you are giving me is the S3 URL. So that's a nicer way of saying what you were trying to say, that I will upload to S3. But S3 you will upload it will be a user bucket. It has nothing to do with, you will generate you can say I will generate a pre-signed URL in my S3 bucket, and that's what I will provide to the service. So service will go and just look at that pre-signed URL and get the job from there. Right? So anyway, but the main things are, you just need to know user, timestamp, and job location. Nothing else really. Everything else is too much details. Not important for the doing the thing, right? Then we came to backend. Backend goes to NoSQL, to database, right? In the beginning, you were discussing a lot about queues, and you were discussing about that publisher thing you had put. Then you removed it, right? Yeah. So that's where I think you need to spend more time now. So I would say whatever we have discussed so far, that was interesting, but you should ask yourself that if somebody is asking these system design questions, they really want to get to the interesting part of the problem, right? They are really not here to listen to all boring stuff, which they think that everybody knows already. So far it's good, but it is not really telling me anything about how smart of an engineer you are. And you really want to show your depth. You want to show that you are, you're not just like, you look at any YouTube video of system design and everybody starts like this so far. But this is where the differences come, right? Interviewers are smart. Like they have seen, we have interviewed tons of candidates, so we know everybody starts like this. But that's where you get into details. Like, okay, let me think about how am I going to do the functional requirements, and especially like, how am I going to? The whole question is about job scheduler. How am I going to schedule a job? And that's the most important part of the whole problem, right? And you discussed interesting trade-offs between schedulers and publishers and queues, but you removed the queue. That's where you need to kind of devote more understanding about it. There are lots of problems which fall under that. The design you have chosen is not the great one. The one you rejected was the better one. I can just tell you as a detail. The design where you had a publisher, that's a way better design than this design, what you have right now. Yeah. Having a message.
This is better?
This is better, but this was better until you explained me that how you are going to use it. So I thought that you were on the right path. So what you will do is that in this case, for example, a publisher will have the same select query. Select star from database where blah, 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 and put those messages in the queue. And the schedulers will subscribe to those messages from the queue, right? And you can have many schedulers listening to the same queue, and then they are the one who is going to forward it. And the publisher, when it runs the, you were talking about, I was asking you, like, how do you know that publishers are not going to because you will have multiple publishers, how do you know that they will not get the same thing? So one way to think about it is to do locks at a row level or a table level or whatever level. So when you're checking certain records, you can lock them so that the next guy, when it tries to get those records, it can't even get those records because there is another guy who's working on it. And then you flip the status. So as soon as you have got the lock on those records, let's say you were doing select star from status not started, and then you flip them to queued. You have changed that status. So the next guy, when it comes in, will not even get those records because you have changed the status from not started to queued. Right? Now, and now because you have a status like queued, and the scheduler what the scheduler is going to do is that will look at all the messages in the queue, and let's say scheduler has got a message and dies, your status will still remain queued because the scheduler never picked it. So after some time, what you can do is that you can look at that which are the messages which were never picked up, remained in the queue, and you can have another service which will re-enqueue them back to the queue because it knows that those schedulers have died. Because why is that? So you can play with the statuses in a very clever way to figure out that which scheduler and which publisher is dying. Let's say publisher dies, then you will never see the status has changed. So you can deal with all these problems. Of course, it gets more interesting when you work with that, but that's where I think that's a better design. The problem right now is that you have a scheduler which is running these queries and also calling the deployment and also sending the notification. A scheduler is doing too many things. A scheduler is querying as well as deploying as well as sending. That's too much work it's doing. So you're not breaking up, right? It's doing a lot of stuff. So, and the notification, right? Again, the notification may go from deployer because a deployer, when it completes it, it can send the notification, but you never said that I'm going to change that status in database. So the main problem with your design is that you were never changing the status. I never heard that when your status is going to change, and that is very important because that's how your records get changed. And because let's say that while you were working with my job, and clients call and says that, hey, what's the status of my job? Database is the truth, right? So the client, if let's say client calls list jobs or get a status, then how will it is still saying not started? These notifications are not really helpful for client because you said you have started, but when it goes to the list page, it says not started. So it's going to cause more confusion, right?
Okay, I see.
So you have to think about it that you can come to database anytime, and it will always know that what is happening to your job.
I see.
Yeah.
So we need to keep this system consistent. Is that like?
It's okay to be outdated. It's fine. Again, those are the things which you should discuss with the interviewer, and then they might relax it. Okay. I think I have to wrap up, but a few more things. In the later you were talking about consistent hashing, and somehow hash will be used as a way to assign. It was not very clear really. How will a scheduler map to certain hash in the NoSQL DB? I think you were trying to, I feel like what you were trying to do is that you were trying to come up with a mapping of schedulers to certain shards in the database. That's not a really great way of looking at it because sharding I don't know, first thing, how will you shard? Like, what kind of sharding are you going to use? Are you going to shard based on timestamps? And then this whole has to mapping to a scheduler is not a great way of balancing the whole act as well. So I think that the problem was that the publisher wasn't there, and then you were using schedulers to directly go talk to shards. But that kind of became a little messy, right? Anyway, that's another one. Status was, I would say, the biggest one, which I felt. And then when I was querying you, kind of probing you about cancellation, that's where the difference comes between L4 and L5. An L5 or a L6 will change the functional requirement themselves to make the system simpler. So I see that you were trying to really allow cancellation till last minute. Let's say if some job is running and somebody sends a cancellation request, you were trying to cancel that job, right? So what a L5 or L6 will do is that they will just put that requirement in the functional requirement that cancellation is allowed up to 30 minutes before the time. You see, smart way. Actually, so that's where you because you were trying to just do the whole thing, but you see that how simple it is to completely think differently. That, hey, I'm not going to make my system super complex, and because supporting cancellation till last minute is going to create too much complexity in my system. I'm going to keep it simple. I'm going to just not allow cancellation after 30 minutes. So, and that's where you see that why Amazon does it this way. Like, Amazon does not allow you to cancel after some time, stuff like that. All that is because of these things, because the system becomes way too complex and you want to keep it simple. You want to be very sure that when I accept the cancellation request, I can actually cancel it. So if, let's say, if a publisher or a scheduler has picked it, you do not want to allow further cancellation, because now you don't know status. You don't know whether its scheduler is working on it. You don't know whether the deployer is working on it. You don't know whether it's sitting in the queue, whether you have sent the notification. You don't want to deal with all that crap because there are too many things are happening now. So that's why you want to work with, so don't just trust the requirements like, oh, I have to do something. If you see that things are becoming very complicated, go back and to the whiteboard and see whether you can talk to the product manager and just change the requirements altogether, because it's too complicated to support it.
Okay, I see.
Okay.
This is a really interesting point. I never thought about it.
Exactly. And that's where you were asking me if you judge me for L5, and I think like, these are the things which you will start noticing when you spend more time in the job, that how things become, why they become the way they become, because of these reasons. Because otherwise you see how much complexity you are adding for just supporting last minute cancellation. It's way too much complex system. And it's very clear if you just draw a boundary that till what time you want to accept it and till what time you don't want to.
Yeah.
Okay. Few things more, you need to take more control of the questions, the leadership part of things, that I was giving you lots of hints throughout. Probably you didn't notice, but I was kind of guiding you toward right path. You might find interviewers who will not give you hints and just waste your time, and then you will fail the interview. So because they will say that the candidate did not, pay attention to the right places. So you need to kind of take the lead, and you need to kind of guess what interviewer might be thinking and go in those directions. So try to make sure that you are keeping the whole conversation engaging, and you're trying to guess whether let's say if you are not clear, it's good to communicate with the interviewer rather than assuming things or going in some direction, right? So don't make the interview super boring, because that's not a good sign. If you really didn't, if the interview was super boring and you did not discuss anything interesting in the entire interview, most likely you are going to fail in that interview.
Okay.
Okay? Sounds good. Okay. I think, I hope this feedback is helpful. I think we have spent a lot of time. Yeah.
Yeah, this is really helpful. I wrap out something
Okay.
to practice in the future. Thank you.
Okay. Cool. Yeah. And best wishes with the process. Yeah. Thank you.
Okay. Thank you. Bye.